Okay, it's 10:50. So I will continue to the next section about symbolic links. And you may have heard the expression symbolic links, and they are also called soft links or symlinks. It's a pointer to another file or directory that we call the target. And it's useful for several things. For ease, of course, if you have a long path you have to write each time you change to a directory. Like, for instance, the project storage directory on many of the systems in Sweden. Then you could make a symbolic link and then just say my storage, cd my storage, and then it goes there instead of typing in something like /project/ my storage directory / my name / something and so on. So I mean, it can be very long, and you can then easier go there. And another reason that is often used is maybe you have some program you are installing and it assumes that there is a specific path or name for a library or something. Then you could make a symbolic link to the actual library from the name of the library that it assumes. For instance, maybe you have a library, dip coolness, and that's what the program assumes it will see. But in reality, what you did get when you installed it was libcoolness 2.0.a, and that's not unusual. It's quite common actually. And then you just create a symbolic link from this one that points to this one. Then when the program is installing, it happily sees this one and continues and just grabs what is in this one, but sees it as that. So that is a very common way of doing it. There are both hard links and soft links. And hard links are also shortcut for files, but not directories. And they cannot be created for a file in a different file system. So if you want to create a soft link, then you say ln -s, and then the real file or folder or library or whatever, and then whatever you call the link. So here, let's say I go up. Let's just go into the exercises one here. And here I have several directories. And under at least, I don't remember, let's check. Under set, there are several directories, and also under piping. So let's assume I want to point to something in this directory here. So I will just do ln -s and then the full path, which would be, let's see, let's go with the really full one. You get this with pwd, so I can show you that. So you can for instance go into this directory here. There's stuff here, you do pwd, and that is the path you want to set. And let's assume you want a symbolic link from this directory here down into this one. So do ln -s and then copy this one here. That's the full path. And then I will just call it go image. And you can see here, there is now a symbolic link called go image that points into this directory here. And if I say cd go image, I am now in the directory you can see here before. It does, however, not show on this prompt here. And if you do pwd, it sees it as if it's directly here. But it works to go directly there, and you can work on it, and you can use it in programs. So, what if it was instead a hard link? Well, then you would just say ln instead of ln minus s, and again the target, the source file, and then the linked one. Let's go up to exercises, and then I will make a hard link to I can do it in the same directory. For instance, let's maybe go into piping and see what files we have there. Let's make one called numbers. That is the real file. And let's make one called copy, just for the fun of it. And now there is both copy and the file. It's there. And as you can see, it doesn't show as a symbolic link. It shows as if it's the same one here. And if you look inside of it, it has the same content as the one we copied. So this is a hard link. And if you want to verify it's a soft link or hard link, you can run this here on, and now let's do it on the file numbers and on copy and see what it says. And it tells us that they are the same. What happens then if we go and check go image? It tells us it points to this one here. So then you will see what is the link point. So let's try a few examples, and I will do this quickly because not much time. So let's code along here, and let's go to the redirect link directory. It's this directory here, and let's create a file to play with. I will just copy this here. There. And like I did before, I try create a test file. So you are doing what I just did before, and I'm just following a link file. I will try look at it. And here you get an output, and there is something here I want to mention. That is what is known as an inode, an index node. And that's a concept in Linux or Unix. And every object in file systems are represented by inodes. It's simply a data structure that stores basic info. And it's not important, but you can see that if they are the same, then you know the file is the same. And there's more info here if you want to read it. So to create a symbolic link, you do also what I did before. You can go up one, and then you can create should start at home, should work. And then exercises and redirects. And then I want to put it in $home and call it Excel, because then I actually get a link in my home directory that can put me directly here. So let's go up one. And let's see what exa is. Exa is a link to this place here. I will do sexa, cd exa. I'm now inside of the redirectory. And there are a few other examples here where you can create a symbolic link to a file in the same directory. And you can create one to a library, as I explained at the very beginning. That you would do this if you wanted to make sure the program will find the name of the library that it expects to. And you can do it in another directory also. If, for instance, you have installed the library in your home directory, but it expects to be found in the user lib directory, then you just make a symbolic link there. Again, the program sees it there, it's happening. To remove a symbolic link, you can either do unlink or you can simply remove it. And you can remove multiple symlinks with RM, whereas unlink can only take one at a time. Just one warning, when you remove a symlink to a folder, don't include the slash, because then bash thinks the symbolic link is a folder and you can't remove a folder directly. With RM, you would have to use -RF or something. Okay. We are 1 minute past 11. That means it's a break time. So let's take a break and then come back 1:15 and do the last session about archiving, compressing, SED, and a few quality of life things. So break time.